Well, I guess we'll get started. Hi, my name is Matthew Wilson. Let me plug in my projector. That'd be a good idea. Let's see, feel free to laugh at the subtitles since I don't know what they say. So. Yes, fork all the things. Anyway, I'll get started. So I'd like to talk today about forking and about forkability in general. But I want to start with talking about some properties of proven systems, systems that have been used, that people have used formal methods of computer science to prove the correctness of them, of certain properties. Here are some of the properties of systems that are reliable and assured and proven. We can make statements about software to say they are correct by construction to certain properties, to certain models. We can verify their correctness if they're fully specified. Well, to the degree that they're specified and we understand their model. There's also tools to create proof-carrying code where software carries its own proof with it, its own mathematical logical proof with it. These proven systems also have tools where they're independently verifiable from the outside, like with a microscope or some other kind of scanner, just to determine whether or not the actual device or software matches the original design. These devices or systems can also be tamper-proof or tamper-evident, a very valuable property which we don't have right now. So, why are formal methods necessary? Well, never mind. Okay. Basically, if it's not proven correct mathematically, if there's no logical model to prove its correctness, it's wrong. And this holds out. Anyone who tries to make a logical model and prove their software in a proof assistant, they're going to fail for any program larger than a few lines, of course. So the only way to achieve security and reliability and therefore privacy and anonymity in the long run is with precise and composable specifications that are proven correct, whose usages are proven correct. So who has been working on this? Well, governments and militaries for decades, of course. They have these systems. They have these capabilities to make certain claims about their software, that it's tamper-proof, that it's correct, that it does what they say it's going to do, what they believe it's going to do. But we don't have it in the worldwide general public. We don't have these verification systems that are nearly as powerful. Why? Because people generally think that the formal methods, they think that the tools are unusable, indecipherable, and expensive, and only 1% of the best PhDs can use them. And people believe, and managers and businesses believe, the development process that uses formal methods is uncertain and difficult. So also developers question whether they're useful at all, or whether it even works, whether it's even possible to make truth claims about software, about what reliability of certain software. So there are some open source tools that are working on this, proof assistants, model checkers, specification languages, but very immature. Still very immature. Makes you wonder. So there are also open data movements, open hardware design movements, but my claim today is that open source systems and open source software can be so much more open, open source than they are right now. So I want to try to give you a vision for a new way of developing software and deploying software and maintaining systems that is much more forkable and much more open, and therefore we will be able to build our verification tools on top of it. And I'll explain why in a second. So I'll just skip that slide that just talks about the startup I've started here and the way we're going to make money from it. So this is what I was trying to say. If a software or a system component is not immediately or instantly forkable at any granularity, that is, any sub-portion of the software system, any section of code or module or dependency or deployment configuration, then my claim is that it's not as open source as it could be. It's not as modular as it could be, and it's not as open source as it could be. So here's an even stronger claim, and I'm saying that if a software or a system component is not instantly forkable at runtime at the same level of arbitrary granularity, it's also not as open source as it could be. So these may sound outlandish, but just stick with me here. So what I'm proposing here is a new system, a new web platform, in order to make everything forkable. And I'm just going to go through a few of the components here in these 3 slides. Some essential aspects and features of this system that I'm proposing that lend it its power. Part of it is that it's an in-browser platform where browsers can communicate with each other P2P over WebRTC. That is, tunneling, OTR for perfect forward secrecy, and onion routing style for anonymity. But the idea is to basically enable you to create an independent computer system within your browser that is just like a full public node on the internet with all its ports exposed and that has full IP capability. And so this is an essential part of it. So another aspect is that the storage of this system is a fully encrypted disk image in the browser, stored via local storage in JavaScript, when it's offline, of course, but can sync up to anybody's cloud, like if you're logged into Box or Dropbox or Google Drive or GitHub, especially. So the first delivery model is to run on GitHub pages. Now, I don't have any diagrams here, so congratulations if you're able to follow me with your imagination. But I'll take questions, of course, anytime. If you would like to take a question or ask a question, please do so. The idea that I'm trying to push here is that we need to stop thinking about separate stages in the development and the maintenance of software and software systems. And that, yeah, while it does add some benefits, a lot of benefits, I think the detriments outweigh the gains. And so what I'm trying to say is that we need to create a development environment in the browser where as you're designing software, you're also testing it, you're also publishing it and deploying it, and it's running at the same time. And again, it could be outlandish until we talk through all of what I'm going to explain here. So again, pushing the envelope even further out to outlandishness. My initial idea is to use 3D visual programming. Pretty confident that it will be, at least a really, really effective experiment with proving the workability of this. And so it's kind of modeled after the metaverse. I'm sure everybody's familiar, or most people are familiar with that. I was sort of. Okay, let's see if I can explain this here without a diagram. Actually, that's going to be really hard, isn't it? Okay. I'm sure Ingy could do a much better job explaining. Let's see. Okay, well, let's start by saying this. What happened to my POSIX slide? I mentioned POSIX in here somewhere. Where's that? Way up? No, way back here. Sorry, okay. To start, what I would like to build is like I said, a development environment in the browser based on mscripton and the JavaScript port of LLVM in the browser, where we will have a bash shell in the browser, fully self-contained, but not running on a Linux kernel. Like, there's an ASM.js port of a Linux kernel that runs in the browser, but it's really, really slow. My idea is to just finish out what the mscripton people are already working on, which is fleshing out the POSIX platform in the browser, so that we can compile, so that we can use the browser environment as a standard Unix compilation target. So we can build our C-based software and C++-based software in the browser, compiled to JavaScript, of course. So that, starting with that, is everybody following me here? What I'm trying to describe is you're working in your web browser, but it's just like a virtual machine, where you have a console and it's just like it doesn't have the same windowing interface or video interface yet, but you're able to install software and download software to your local file system in the browser, but not the local file system in your real operating system, just the one in the local storage. This is a virtual file system. And so I guess what I'm trying to say is this is how to create a very, very lightweight virtual machine inside JavaScript in the browser. And then building on top of that, this 3D development environment world, where as you're creating things, as you're using the 3D editor in this world, you're pushing your changes to GitHub automatically. You're real-time editing, software artifacts on GitHub, which do have a text-backed interface, of course, or text-backed storage. But you push your changes, and somebody else goes to your website or to your GitHub Pages site in this case, and they click fork to the same environment that you're editing, and suddenly they see a copy of what you're editing. So it's very it's similar to the real-time collaboration of Hackpad and EtherCalc, but in this case, it's using Git as the synchronization mechanism in the browser. And so the idea is you're working on your Kaleidoverse or your development instance, and we're calling it a reality here, and you push it to a branch from your browser, and you tell somebody how to find it, and they go there, and they fork it. And then they set it to automatically pull and merge from you. And so as you're creating software artifacts in the browser, typing, coding, or point and click or touchpad interface, they're seeing your changes appear on their screen. Just like, like I said, just like those online real-time collaboration interfaces. But then you can set your system to pull and merge from theirs explicitly. And here's an example, but it's probably gets too hard to explain there. So let's see here. So anyway, my basic claim was that I know I started with the formal methods and the verification, but my basic claim is that we need to erase this distinction between design, test, publishing, and deploying and running, so that we can have software that verifies itself eventually at one level, and is not complex or not too complex to to be fully verified. So it's kind of a loose argument there, but I'd like to pursue this because Well, there's a whole lot of other benefits to this system other than, like I said, enabling the new development tools. But like I was trying to explain how it's a more generic way to do real-time collaboration, like Hackpad and EtherCalc, of course. But I think one of the key aspects is is what I mentioned with the anonymity. Being able to collaborate peer-to-peer in the browser anonymously, essentially through a version of Tor. And if you can separate that aspect of using it out from this design time aspect of using it, I think that's where the real power of this is going to be, where we can build fully serverless applications, that is, fully peer-to-peer applications, but we have to have these specific components in order to do it. So that's what I'm proposing. I'm proposing building these components I've described so that we can have a serverless web platform peer-to-peer in the browser with a full Unix-based compiler toolchain. And then I'm also throwing in there a bunch of confusing stuff about 3D worlds and metaverse stuff, but it's mostly to spur your imagination. I'd like to think anyway. So anyway, just my last slide here. Let's see if there's a.
It's like Snow Crash's metaverse, but anybody, instead of there being one metaverse, everybody can have a metaverse and fork anybody else's metaverse at any point.
Yeah.
And then also, as they're living out my fork of your metaverse.
Speak up.
Oh, as I fork your metaverse because I like what you're doing, or I'm interested, or maybe I'm suspicious of what you're doing. I take a look around, and now it's my metaverse. I change things like I would fork a repo, and then I can push changes back to you, or request that you pull changes back. So like applying the GitHub model to the Snow Crash story, as it were.
Yeah, that's right. So I guess I'll take some questions. Let's look at the subtitles here. Anything hilarious here that I'm not getting? Anyway, what I'm proposing is to talk about this tonight, tomorrow, and tomorrow night, and then have an actual in-person hackathon on Sunday to continue some of the efforts that have been started on this and try to find some smaller projects to tackle. But I and some other people have done a lot of upfront design work already. Imagining how to implement a lot of these things and proving it out theoretically, and so we have a good start. And so I think we could actually make a lot of good progress with the right team on Sunday. But I'm also going to be here the whole week, next week through Friday. I'd like to find some people to work with on next week. So anybody have any questions? Feel free to tell me you didn't understand what I was saying at all, but try to ask a specific question that you didn't understand so I can answer it specifically. Any other questions? Does anybody feel the same way about the necessity of creating, an in-browser, peer-to-peer, serverless web platform? Anybody agree with that?
Yeah, I have a big question. So I don't see the relationship between formal verification or formal method and your platform. I cannot get it.
Yeah, you're right. That's a very loose argument there. But basically, it just boils down to I can't. Governments are intercepting all of our communications and changing them en route. I can't rely on our collaborations until I have secure collaboration using this. We can't trust our SSL and our TLS implementations to protect our integrity. They're just apparently rife with errors, and probably always will be. So I guess what I'm saying is, in order to make any claims about verification and security and reliability and consistency and integrity of software, we need to have a secure development environment with a trusted kernel, with the smallest possible trusted computing base in the browser. This is the way to do it. This is the way I do it. Yeah. Do you see what I'm saying? We don't have, since we don't have security in our development environments right now, full, that we can rely on.
So let me try
Sure.
to see if I get it. So what you mean is that so we want to build a secure environment, but how to prove that we have a secure environment? So we need something like a proof carrying code and etc.
Yes.
But I don't know. I'm not familiar with that kind of proof carrying stuff. But I read some paper before about say 10 years ago. As far as I can tell, those stuff are not practical. I'm not. Yeah.
Yeah, they you're right, but they're not practical, and that's the general perception that everybody has. But it's because the tools are really bad. The tools are very immature. Two of the people that I'm working with in my startup are Jared Davis of ACL2, who works at Centaur, a VIA company, chip company in Austin, and David Van Horn, who's a professor at University of Maryland working in this area. And they both believe that there have been recent breakthroughs in usability of these tools, that that will make them a lot more accessible and a lot more usable, a lot more practical for all of us to use. All of us mortals who don't have doctorates in verification and formal methods, to be able to say that we know our software does what we think it does, and say it's bug-free to the extent that we know what bug-free means. So that's where we're heading. We're actually working with a large team of researchers to explore these practicality things, and I'm sponsoring writing some essays, and so there will be some essays published from the top researchers in this field in the next 6 to 8 months or so. So that addresses that, but what I was going to mention was the core security kernel that we can trust in the browser is a system called defensive.js. Well, it's one of them. There's several of them, but if you go to defensivejs.com, it's let's see here. This is just one example of getting started with a secure kernel. There's several other aspects that need to be included, like sanitization and sandboxing, but there's some libraries that do that very well. But this is kind of the core in crypto kernel that proves itself correct continually. Now, like you said, we're not going to have a secure environment unless we can also trust our hardware devices, or our operating systems at every level. If we've already been hacked, if your phone has backdoors and vulnerabilities in it because it has 3 other coprocessors that can control, Android or iPhone, then you can't rely on it. So yes, we also need verified hardware designs eventually to be able to trust our systems. But until then, we can't trust anything. We can't rely on the integrity or the security or safety of any of our devices, any of our software. So that's why this is crucial. We won't have privacy. We won't have anonymity. We won't have reliability, and we won't have safety from protecting against remote control until we have proven correct software, full stack. And so that's my strong claim, is that's why this is so important. there's so many vulnerabilities and so many attacks. This is the only way to get as safe as possible, as strong as possible, long term. So any other? Did I address your question well enough? Okay. Any other questions? Anybody? Any comments? Suggestions? Skepticisms? Critiques? Tomatoes? Yeah.
I have a small question. Why do you prefer to run the program you were talking about inside the browser rather than as a native application?
Just because that's the kernel that everybody can use without downloading or installing anything at first. Yes, we do want to have a target platform that is like a Google Chrome plugin or what are they called, extensions, like native client that does verify certain security properties of its code. But until then, I think it's best just to keep it at one level. That's very, very easy for people to just one click. Suddenly they're in a secure development environment, by clicking a hyperlink or something instead of needing to download or install something. That's the idea. See what I'm saying there?
Yes.
Okay. Well, we have three minutes left, and we can end it now if you'd like. So thanks for listening. Thanks for trying to follow. Thank you.